Today our topic of discussion is work, power and energy. What is work, what is power and what is energy? Work in our daily life we do many work of different type. For an example, I'm coiling this marker. This is also a type of work. Suppose I'm lifting this whiteboard upward direction. This is also a work. I'm making my hand upward and downward. This is also a type of work. I'm lifting this marker and again coiling this marker. So this is also a type of work. Many people work by pulling the rickshaw. Many people work by digging the earth, and such type of these, basically we define these are the works. So what we have to do, we have to just convert this work which we do in our life, daily life, in a mathematical form. We have to basically develop a mathematics for this type of work. What is the category of that work does not matter. For an example, I have this marker and I am displacing this marker from A position to the B position. So I am working. So how much work basically I did to displace this marker from A to B position? In general, this is very difficult to define mathematically. By mathematics, we have to define this work. So for that, what I am doing, I applied some force. I am applying some force on this marker at this particular angle with respect to the axis of this marker. So comfortably I am displacing this marker. But when I applied in this way, almost parallel to the direction of displacement, so it is very easy for me. So now if I am changing some angle with respect to the direction of displacement, like this one, so now suppose I want to displace this marker from A to B position, that will be very difficult. At 90 degree it is very difficult. So it means this is the direction of the force exerted on this marker, and as a result this marker is shifting towards the B point. So how much basically this displace, that is, suppose S. So S is the displacement. I have applied some force here, and as a result this object displaced from A point to B point. So this is the displacement, and the second factor is force. So there are only two variables which comes into the work. One is the force which we apply, and here right now I am the external source. I am the source of this force, and how much that displace on the ground, that is from A to B. So now the point is we have to develop a mathematics to define the force and displacement and ultimately the work. So I have to develop a mathematics for the work. So the definition of the work is W is equal to F dot S, where F is the force, that force by the external source, S is the displacement, and this dot represents the scalar product between the force and this displacement. F is the external force, this is external force by which this object displaced from A to B position. S is the displacement. and this dot basically completely represent to the scalar product. This is a scalar product. So before we go into the detail of the work, what is work, how to define the unit of the work, and the type of work, this is positive, this is negative or zero. Before we go into the detail of the type of the work, we have to understand the scalar product between these two vectors. Force is a vector quantity, displacement is also a vector quantity. So what we are doing here, we are just taking a scalar product between the force and this displacement. So in general, and as a result, what we are getting a scalar quantity W. So work is a scalar quantity. It means we are getting only magnitude. So work has magnitude, no direction. So what we are doing in our daily life, basically that's have only magnitude. We are saying that we did so much work, like 2 joule or 3 joule or 4 joule, like this one. Or in terms of CGS system, we can say that we are measuring our work into earth. So what is this vector? Basically this is scalar product. So now we have to focus on the scalar product before we go into the detail of the type of work, that is positive, negative or zero. So what is the scalar product? So a scalar product, we are basically taking between two vectors, and here our two vectors are force and displacement. So I am erasing this board. That means I am doing some work to erase this. As a result, I am getting this white clean board. So I did some work. So how to basically convert this into a mathematical form? So for that, scalar product is the first point. I have two vectors, vector A and vector B. This is a mathematical notation between these two vectors. Vector A dot, this is dot vector B. So A dot B is equal to AB cos theta, where A is the magnitude, of vector A, and this is represented by mod of A square, mod equivalent to the vector A square, like this one. So this is magnitude of this vector A, and B is the magnitude of vector B. Magnitude of vector B. Theta is the angle in between these two vectors. Suppose this is our particle and displaced along the positive direction of x-axis. This is positive direction of x-axis, and this one is the P point. Initially the particle was at A position, and this is final position, and this is positive direction of x-axis. So when I apply a force into a particular direction, so it makes an angle, this is theta, and particle displays according to this direction. But for the explanation of this scalar product, I have this vector A along the positive direction B. This is the direction of other force. For an example, this vector B making an angle theta with this vector A, and this is the projection. This figure A, the projection of vector B on the vector A. If I am saying this is O, A, O, P, and this is further O, Q. So, and this one is R. So QR is perpendicular on OP. So this basically, this distance is equivalent to the B cos theta. This is B cos theta. B cos theta means the projection of vector B on OP, on vector A along this direction. So this is the projection. So you can write this scalar product A dot B is equal to AB cos theta in this way also, A B cos theta. It means A is the magnitude of vector A and B cos theta is the projection of vector B along the direction of A. The other way is you can write here B and this is A cos theta. So right now B is the magnitude of vector B, A cos theta is the projection of vector A along the direction of B. So the second situation is you can make, so I have this vector A, this is OP, and this is vector B, this is vector B, angle theta. So now what we are doing, we are just drawing a perpendicular from vector A to vector B. So suppose this is perpendicular on vector B. So P, Q you can say. So this distance on vector B is A cos theta. This is A cos theta. And this is known as projection of this vector A on the vector B. There are two things. One is B cos theta and second is A cos theta. A cos theta is this one into the second picture. This A cos theta is the projection of this vector A on vector B. Here this is B cos theta. This distance is B cos theta, magnitude only, and this is the projection of vector B on along the side vector A. So these are the meaning of these mathematical quantity which are magnitude. A is also magnitude, B is also magnitude. From cos theta we can find out the numerical value. So everything is basically in terms of magnitude. So these are, when these multiply, this gives a magnitude in a number, in terms of a number. So work basically is a scalar quantity. The point was related to the B cos theta and A cos theta. What does it means? We are writing in general a scalar product A dot B is equal to AB cos theta. Further we writing this AB cos theta in two ways. One is A and this B cos theta. Second, B A cos theta. What it means? It means according to this picture, this is a vector A, this is vector B. Vector B is making an angle theta with the vector A. Now I have to find out the projection of this vector B along this direction. So the projection will be draw a perpendicular on this vector A. So this OP will be projection of this vector B, and this projection is, we can find out that is B cos theta, where theta is this angle. So projection of this vector B along the direction A is B cos theta. And here we are finding out the projection of this vector A along the direction of vector B. So the projection of this vector A on the vector B direction. So draw a perpendicular from this, from the point P on vector B that will cut at this point Q. So this distance basically will be projection of this vector A on vector B, and that will be A cos theta. So A cos theta is the projection of this vector A. B cos theta is the projection of vector B along the A direction. A cos theta is the projection of vector A along the B direction. So these are two major important points to explain this scalar product between two vectors. And as a result, what we are getting just magnitude. So similarly, this is our object at this point, and we applied some force. This is the direction of force, and as a result, when I pull this particle, suppose I am pulling this particle along this direction. So as a result, this particle is moving into positive x direction. So this is the real situation. So we are interpreting our physical situation into graphical view, and then after we are developing from this geometry a mathematics, and this is our mathematics to define the work. So this formula basically we develop from the vectors geometry, and we use this geometry to define the work, where these are the only two important points. One is B cos theta and second is A cos theta. A cos theta, again I am repeating here, is the projection of this vector A along the direction of B. So this is A cos theta, and into the same direction this is vector B, and here this is vector B, this is vector A. I am finding out the projection of this vector B along the direction of A. So this is the B cos theta along the same direction of A, and total result is A dot B is equal to AB cos theta. Now in general, how to define vector A? Vector A is equal to AXI plus AYJ plus AZE, where I, J, K are the unit vectors. AX, AY, AZ are the component of vectors, and these are magnitude along the x direction, along the y direction, along the z direction, where I, J, K caps are unit vectors. These are unit vectors, and magnitude of each vector is equal to 1. Magnitude of each unit vector is 1. So Ax, what is Ax? Ax is the magnitude of vector A along x direction. So Axi is the projection of vector A along the direction of x-axis. Similarly, Ay is the projection of vector A along the direction of y. Az is the projection of vector A along the direction of z. For an example, I am selecting this Cartesian coordinate system. This is x, this one is y, this one is z. So this is my vector A, this is vector A. So the projection of this vector A on x-axis, that will be Ax. So this is Ax. Projection of this vector along the y-axis, that will be Ay. Projection of this vector along the z direction, so that will be Az. So Ax, Ay and Az, basically projection of this vector A along the x direction, along the y direction and along the z direction. These vector components are defined through this I, J and K. These define that vector component. Now this is only magnitude along the direction of x, along the direction of y, along the direction of z. But when we consider Axi, this is vector component along the direction of x-axis. This complete form a by j is the vector component along the direction of j, y, and similarly this a z k is the vector component along the direction of z. So contribution of this vector a along the direction x, along the direction y, and along the direction z. So this is the meaning of vector a. Now we have second vector for an example vector b, that is equal to bxi plus byj plus bzk. So we have these two vector, vector a and vector b, and the meaning of vector a is similar as of the vector b. So these two vector, vector a and vector b. So I have chosen this example to define a. The same will be applied for this vector b. So now we have to find out the scalar product between vector a and vector b according to this formula. This formula says that vector a dot vector b is scalar product between these two is equal to ab cos theta. Now according to the definition, vector a is equal to axi plus ayj plus ezk. Vector b is equal to bxi plus byj plus bzk. So these are the two vectors in general form. Ax, ay, az are the numerical value. So I can write that for vector a, suppose ax is equal to 2, ay is equal to 3, az is equal to minus 4, like this. So vector a becomes ax is equal to 2i plus 3j minus 4k. So this is the actual form of vector a, but in general to develop that mathematics we are using vector a is equal to axi plus ayj plus ezk. Vector b is equal to bxi plus byj plus bzk. So now the scalar product. Now I have to put this value of vector a and vector b into the left hand side, this side. So I have to find out the result for vector a dot vector b. So this is equal to ax. First of all I have to write the value of vector a, that is axi plus ayj plus ezk. This is vector a dot scalar product between second vector, that is vector b xi plus byj plus bzk. So now I have to find out the scalar product. This is product, but this is not same as 2 into 3 is equal to 6. This is product, mathematical product, but this is vector product. Vector is scalar product. So axi, first of all this axi, and then after bxi, again axi byj, ax bz I dot k. One important point is here. We know that I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. Why? Because magnitude of two same unit vectors is equal to 1. When I am putting the value of a, unit vector I, this is unit vector I, magnitude of I will be 1, this is will be 1, theta is equal to 0. So what we are getting, this is basically two parallel. Why these are parallel? because we have developed in Cartesian coordinate system this any vector A, projection of this vector, that is Ax. So vector component of this particular vector A along the direction of x, that will be xi. So if I have to consider again this another vector and the direction, suppose that is bxi, it means both the vectors are parallel. This I represent that vector component is along the x direction. Same will be applicable for this one. So this is bxi, it means this bx vector component is also into the same direction. So this is bx, upper one is ax and lower one is bx. If we are writing any vector into this form axi, bxi, it means both the vectors are in same direction. For an example, these two markers are into the same direction. So both are basically parallel. That's why the angle in between these two vectors will be equal to 0. So when I putting the value of unit vector I here, this is unit vector I dot, unit vector I, magnitude of vector I is equal to 1 into 1 and cos multiply, this is mathematical product, cos 0. Cos 0 again equal to 1, so 1 into 1 into 1 is equal to 1. That's why I dot I is equal to 1. Similarly, we can find j dot j, ayj and bzj, byj. Both vectors are parallel. That's why angle in between these two vectors, this by and this ay, will be same, that is 0. So I dot j, j dot j is also equal to 1. And similarly for this k dot k is equal to 1. But when we consider I dot j, then what happens? I dot j means I am considering this axi. This axi means vector component of A along the direction of x-axis. Axi means this vector component along the direction of x. And second is the j for the this one, byj, this component. It means this component will be along the y direction. So it means the angle in between unit vector I and unit vector j, that is 90 degree. So now I putting here vector A is equal to I, vector B is equal to unit vector j. So magnitude A of this vector will be equal to 1 into magnitude of vector j, unit vector j, 1 into cos 90. Now cos 90 is equal to 0. So the total result becomes 0. So it means I dot j, j dot k, again both are perpendicular. This is j direction and this is k direction. So angle in between these two 90 degree. That's why j dot k will be equal to 0. And this k dot I further, this will be equal to 0. So only when I dot I we consider the unit product between the same unit vectors, that is equal to 1, I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. But with the other unit vector, for an example I dot j, j dot k or k dot I, the scalar product between these vectors will be equal to 0. So we have to keep remember these results between unit vectors. When I dot I is equal to 1, I dot j equal to 0. So our scalar product between these two vectors, so axi dot this bxi plus axi, now for this axi dot byj plus axi and this bzk, axi dot bzk, and similarly the scalar product with this ayj, bxi, byj and bzk. Now this plus sign, ayj dot this bx I and then this with this by, so ayj as it is dot product with the by component, that is j also, plus this component same, and with this component ayj dot bz key. Now for the third component of this vector, this plus side, this azk with this bx, and again for the second term, and then after for the third term. So we expand this scalar product in this way. So azk, this term, scalar product with the bxi plus azk, this scalar product with the by component, that is j, plus this az k as it is, and dot product with the last term, that is bz k. So this is the expansion of the scalar product between vector A and vector B in terms of component. Now we have to use that property. Which property? Property of the unit vectors, where I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. Rest of the product will be equal to 0. For an example, I dot j is equal to 0, j dot k equal to 0, and k dot I is also equal to 0. And similarly j dot I dot j or j dot I is also equal to 0, k dot j equal to 0, I dot k is also equal to 0. So now using this property of the unit vectors, we can write this term here. This is axi dot bxi. What is ax? This is magnitude. This is also magnitude, but this I and this I is a vector. So we have to keep both together. So I am writing here in this way this term ax bx I dot I, plus instead of this again in a similar way, this is ax and this component by together. Then after scalar product is in between vectors, so I dot j plus these two components together, ax bz, and scalar product is in between I dot k. So here this is I dot k. So now you can use that property. This is I dot I equal to 1. So this term will survive, and as a result this is equal to 1. So you are getting here a dot b equal to ax bx, plus this is I dot j, this is equal to 0. So this term is equal to 0, second term is equal to 0, plus this is I dot k, so this is also equal to 0. So the third term is also 0, plus this one. This is a by bx and scalar product between j and I. So I dot j and j dot I equal to 0. So this term is also 0. This is ay and this one is by. and then after j dot j, j dot j equal to 1. So ay and by, you are getting this term ay by plus, and this is ay bz, and the scalar product between unit vector is j dot k. This is equal to 0. So the third term is equal to 0 plus this is k dot I, again equal to 0. This is k dot j, again equal to 0. So this is k dot k. So you are getting az bz from here. So as a result, what we are getting between the scalar product of a dot b, that is ax component bx component, the same direction, then after ay by plus az and bz. So as a result, we got only same component. So a dot b is equal to ax bx ay by az and bz. So a dot b is equal to ax bx plus ay by plus az bz. Now we can consider any example right now. You after making this mathematical development. For an example, vector a is equal to 2i plus 3j minus 4k, where 2 is ax, 3 is ay, minus 4 is az. This is az. And for the vector b is equal to, suppose bx is equal to 1, by is equal to 2, and bz is equal to 3. So the result, our vector b is I plus 2j plus 3k, and vector a is equal to 2i plus 3j minus 4k. Now we have to find out the scalar product between these two vectors. So this is ax bx plus ay by plus az bz. So vector a dot vector b is equal to ax is equal to 2, bx is equal to 1, plus ay is equal to 3, by is equal to 2, plus az is equal to 4 minus 4, and bz is equal to 3. So the result will be 2 plus 6 minus 12. So this is 8 minus 12. Result is minus 4. So a dot b is equal to minus 4. So basically, what is a dot b? A result of this scalar product between two vectors is a scalar quantity, and this is magnitude, but with negative sign. This result is coming in negative sign. So we have to check basically further this idea with the work. Work is equal to F dot D. Our work definition, which we have developed mathematically, that is F dot D. W is equal to F dot, in our case we have considered that displacement S, so W is equal to F dot S, that means F S cos theta, where F is the magnitude of vector F, S is the magnitude of vector S. So vector F and vector S and this cos theta, theta is the angle in between these two. Suppose this is vector F and displacement along the x direction. So this is vector S. Angle between these is theta. So we have to find out how much basically work is done by the external force to displace a particle from A to B. So that will be work. So how much basically that work? So for that purpose we have to use this formula F dot S, and this is equal to F S cos theta, where this notation is used for the magnitude. Mod of vector F is the magnitude. Mod of vector F is the magnitude. Magnitude of vector F. And similarly this is the mod of S. The way of writing is mod of vector S. That means magnitude of vector S. So F S cos theta is the result of W, and this is a scalar quantity. So by that, this way we can find out the result. W is equal to positive, W might be negative, and it could be 0. On this factor basically, this will be positive, this will be negative, this will be 0. It depends on this important point. If theta lies in between 0 to 90 degree, if theta less than or equal to 90 but greater than or equal to 0, it means this theta varies in between 0 to 90 degree or less than 90 degree. Only then work will be positive. But when this is equal to 90 or up to 180 degree, then this work will be negative. And when work is equal to 0, it means force is applied along the perpendicular direction, along this direction. So when theta is greater than 90 degree and less than or equal to 180 degree, then this work will be negative. And when theta is equal to 90 degree, this will be equal to 0. So suppose F as cos theta. If cos theta is equal to 0, parallel to the displacement, what will be the value of cos? If theta is equal to 0, so cos theta will be equal to 1. But when theta is equal to 90 degree, cos theta will be equal to 0. What it means? It means when you apply any force parallel to the displacement, if this is the direction of force and this is some particular any angle theta, instead of this I am making it 0. So I am pulling that object into the same direction. So work will be positive. But this is the instead of this direction, this is the motion of that object, or I want to shift that along the x-axis direction, and I apply force into this direction perpendicularly in this direction. Okay? Then the work will be equal to 0. But if I pull this object into this direction, what I was doing right now, I am pulling this object in with this particular angle. Suppose object is here and I am pulling like this one into this direction. So this will displace along the direction. When I will force downward direction, it will not displace. When I will pull into this direction, then work will be negative. So this is the definition of positive work, negative work and zero work.